Okay.
All right. So I'm gonna start over because you got to sort of see it in context. So here's the ground.
Mhm.
Okay, and assume like you're here.
Okay.
All right. This angle right here that's made with the ground, this is called the angle of elevation.
Mhm.
Okay. Now let's assume you're in an airplane and you're flying
Yeah.
this way, and another triangle is created. This angle right here is called the angle of depression. Now,
Hmm.
from two parallel lines, we did this a while back, that are cut by a transversal, this angle is the same as this angle. They're called
Yeah.
alternate interior
Interior angles.
angles. So they're actually the same thing. Depression and elevation are the same thing,
Oh.
but they use different words for them for some reason. Like usually this is the depressions in the context of like an airplane or looking down off a building.
Mhm.
Elevation is like looking up. Okay, so we're going to start with question 1, which is actually just asking you to decide which one is the angle of depression. So here is that triangle we're talking about. Which one is the angle of depression?
It would be angle. It would be angle 6.
Well, 6 is down here. I don't know. 6 is somewhere down there.
Oh.
Go back and look at this picture. Which one is the depression?
The top.
The top one.
Yeah.
And which one's the elevation?
It's the bottom one.
Just look at this picture. I made the triangle to like
Oh.
try to like force you to look at this place. Where is the angle of depression?
It is number 4.
Okay. All right. So let's see what else they ask. Okay, so here's another one. Do you have this picture firmly cemented in your head? Like,
Yes.
okay, because the next one is asking the other thing. It's saying what's the angle of well, actually this one just asked for depression again. So we'll do this one side by side. So the angle of depression. Okay.
It's number 7.
It's number 7, right? Okay, good. Okay, and it's a little odd actually that they're spending so many questions here trying to like cement this topic, but it is an important one. Now they want the angle of elevation.
It'd be on number 8.
Number 8 again, or number 8 this time. Good. Okay, so you're definitely getting it. Now we can actually do some of the story problems here. So you're going to need that Desmos scientific calculator again.
Okay.
Do you remember where we found that? Do you need to send you the link to that?
Yes, please.
Do a search here. Do a search for Desmos scientific calculator.
Okay, I have it.
Okay, so you got that same one we were talking about last time?
Mhm.
All right. All right, so the challenge here with these questions is you gotta be able to draw the picture. When observed from the top of a 250-foot tall lighthouse, the angle of depression of an approaching ship is 50 degrees. So here, like if you want to make a really cool drawing, you can do this. Here's your lighthouse, here's your ship. Okay.
Mhm.
Okay, but you don't actually need to do all that because all you really care about here, I mean, you could switch colors, is you care about the triangle that's formed.
Yeah. Yeah.
Okay. So the 250-foot tall lighthouse. Now the angle of depression is 50 degrees.
Yeah.
And what did I say earlier? The angle of depression and the angle of elevation, they
Are
are
the same.
So this is also 50 degrees. And we want X because
Okay.
we want the horizontal distance. So from last time, there are 3 trig functions. So, sine, cosine, tangent.
Mhm.
Relative to this angle, what is this side and what is this side?
250 is opposite and X is adjacent.
Okay, so the tangent of 50 degrees equals 250 over x. Go ahead and solve that for x, please. I'll be right back. Let me know when you get a final answer on that one.
Okay. I get 210.
Good. Okay. All right. The picture really helps, doesn't it?
Yes.
So most students struggle with finding the picture, and kind of rightly so. I mean, the picture is a challenge. Okay. So a man standing on a lighthouse. I think it'd be in a lighthouse, but anyway, at a height of 124 feet, signals two boats directly in front of him. One is at an angle of depression of 62 degrees. The other is an angle of depression of 33 degrees. Identify the two boats. Okay, so we're not going to draw the picture. We're going to draw the triangle. So in the first scenario, this is 124 feet. Do you agree with that? That's the height. Okay. And the first one that has an angle of 62 degrees. So this is also 62 degrees. You agree with that?
Yes.
Okay. Now we want to find this distance right here. So we're going to use tangent again. Tangent of 62 equals 124 over x. Now in your calculator there, I hope you're doing the following. I hope you're doing 124 / tan 62, because you can do it all in one step, and I want you to do it that way. That's the right way to do it.
$65.9.
Okay, so we'll call it 66 maybe.
Yeah.
Okay, now the other scenario here, and there's another way to draw it, but I'm doing this for simplicity. This is 33 degrees, and this is 33 degrees. So go ahead and solve that for x using the same approach as before. I'll be right back.
Okay.
So I'll write out the steps here. Tangent of 33 equals 124 over x. X equals 124 over the tangent of 33.
Yep. I get 190.9. So
So
190.
we'll call it 191. So this one's further away, and if you recall, it wants the distance between the two boats. So one boat's 191 feet away, another boat is 66 feet away. How are you going to find the difference?
Subtract or
Yeah.
oh.
You have that final
100,
answer?
125 feet.
Very good. All right. All right. So 16. I'm sorry, this is our last question here. Did you get the notes down for this one?
Of oh.
Did you take notes on this question?
Not yet. I'm still going through them.
Okay, I would recommend writing this one down because the next one is exactly the same, and I'm gonna have you do it on your own. So do you want to get the notes down for this? Or do you just want to move on to the next question?
Let's move on.
Okay, so I'll let you work on this one on your own. It's exactly the same, just different numbers. Take a couple minutes to work through that, and we'll move on to the next section.
Okay. I have my final answer.
Okay, what is that?
26 feet.
Excellent. Great. So these are just word problems associated with the stuff you've already been learning.
Mhm.
And now we're going to move on to a new section, which is, I think, probably the most difficult part of this class. It actually doesn't even belong in geometry, in my opinion. It's more of like what I would consider trigonometry topic. But we'll see. We'll see what we can do here. It's called the law of sines, whatever that's worth here. So first question is actually just go to your calculator and find the sine of 172 degrees, which I think you already know how to do. So I'll let you run through that.
0.139.
Okay, so to 2 decimal places, what would it round to?
1.4. I mean 0.14.
Good correction there. All right, so the next one is actually the sine of 157.
Did you say 57?
157.
Oh, 157.
And yeah, I'm sharing my screen still. I wrote it down. 2 decimal.
0.39.
Okay. You're probably thinking to yourself, is this it? I got this down. I don't know what they give you, actually 4 of these, so we're going to do these first.
.68.
All right, let me check here. Nope, that's not correct.
Oh, to cos. That's
No, don't say that.
oh, cosine.
Cosine. Say it correctly. It's important. It's just like your name.
.73.
Good. All right, the last one here is tangent 176 degrees.
Negative 0.069, which would be 0.07.
So you said all the right things, but if I go with what you said the second time, it would be different than the first time. Give me the answer to 2 decimal places.
0.06.
Okay. I'm going to snip in the answers this time.
Sorry, negative 0.06.
So that answer is not here. And why is that? Well, let's take a look.
Well, because there's nines after that, so it's going to be 0.07.
Right, so it rounds up.
Negative, sorry.
Right, and it's important because let's say you're measuring something in a car, and you're trying to fabricate. I don't know. Let's say you're trying to fabricate something to like go on the back end of a Jeep, like on a I don't know. I remember someone was telling me one time about these tailgate stoppers, and they don't always have holes, right? So you might have to fabricate the position of where you're going to put a hole. And your tool, you're going to end up rounding. You're going to say, oh, that's 1.9 inches or something. You don't say it's 1.8997. That's why we round. That's why it's important.
I
Does that make
understand.
sense? Does
Yeah.
that make sense? Okay. So before we can go on to the actual law of sines, and actually this is a really cool reference sheet I'm going to have to do pretty soon. So this is great that we're doing it. Let's say this is your triangle A, B, C. Angles are always big letters. Sides are little letters. Okay, and someone came up with the following. They said that A over sine of big A equals B over sine of big B equals C over sine of big C. Oops. Okay. And the way you use this, there's actually like three flavors of this. The first one is when you use these two. So or you use these two. So what do I mean by that? It's A over sine A. Gosh, I keep doing the wrong one. Equals B over sine big B, or B over sine big B equals C over sine big C. But you can also use the first and the third. You can use this with this, and that's A over sine A equals C over sine C. Do you follow how I created each of those three?
Yes.
Now here's yet another permutation of this. You can actually flip all of these. If you're
Oh,
not sure what I mean, it's where the sign is now on the top and the letter is on the bottom. Okay.
oh,
Now, if we go back to what this actually means, do you see how A and big A and little a are across from each other?
yeah.
So I call these pairs.
Oh,
That's a pair, that's a pair, and that's a pair. And you're looking for pairs when you do this. And we're not talking about the fruit, we're talking about like they have to be joined together. So it'll make more sense as we do some problems. Unfortunately, they give you probably a little too difficult of a problem to start, but I'll do my best here to simplify this for you as we go. I'm going to step you through it. You don't need to do anything unusual here. So they give you information here. They tell you that this is 22 degrees.
hmm
They tell you that this is 65 degrees. And they tell you that S is 176.
oh,
So notice that they give you, I'll do it in blue here. They give you this as a pair. Do you see that?
yeah.
And Q is a pair with this one. Do you see that?
It is, but it doesn't have. But the little q doesn't have a number.
But
Or,
that's right, but we're going to use the law of sines. So here's the law of sines. You choose a side, for example,
mhm.
Q, and it goes with the opposite or the one across from it. Do you see how that Q goes with Q?
Yeah.
Okay, and that equals, and it goes with any of them, but you want to choose the one that's given. S over sine big S. So now we can substitute in the numbers that we have. Do we know the angle of big Q?
We we do.
It's 22.
Yes.
Do we know little s?
Yes, we do.
Do we know big S?
Yes, we do.
Okay, so how many variables are remaining?
Of there's two variables remaining. Well, wait. Sorry. Since it's a pair, it's actually one. So,
What's the variable that's remaining?
uh, P and P, the pair here.
Well, you're looking at the picture. I'm looking at the equation.
Oh, oh, it's Q. It's little Q.
And that's what we're trying to find. Okay, so I want you on the right to calculate this number to 4 decimal places, please.
Okay. I get 194.19.
Like that.
Mhm.
Okay, give me sine of 22 to 4 decimal places down here.
Okay. I get 0.3746.
Okay, so how do you solve something like this? It's q over the divided by this number. How do you undo the division?
You multiply
So you multiply both sides by
by
0.3746. Okay, and that'll give you your value of q.
okay.
Do you have an answer for me?
Oh, I'm almost there.
Okay,
I get 194.19. That's weird.
I think you should try your calculation again.
So I multiplied these. I multiplied 1.94.19 to 0.3746. So times 0.37. I get 72.7435.
That's correct.
I'm sorry, what?
There's a lot of background noise. Is there something you can do about that?
Yeah, give me a minute.
Okay.
You can go and plug your computer in there. So I'm gonna go. I'm moving my computer away.
Okay, so
Hey, Christopher.
hey,
So did you get the sine of 176 divided by the sine of 65 is 194.19? I mean, that's what you told me.
yes,
Okay, and then you're going to multiply that number
yes,
by what?
by 0.3746, and I get 72.74.
Good, good. Okay, that's really good. Now, let me show you kind of the way I want you to do this problem in the future. So remember we wrote this down.
Yeah,
So you can actually do the following. You can actually multiply both sides by the sine of 22. And this looks complicated, but your calculator will do all of this for you. 176 times the sine of 22 over the sine of 65. So if you're using that calculator I showed you, it can actually do all that in one step. And that's what I want you to be able to do. So let me show you that here. That calculator I gave you will do this. Do you see how you can type all that in together?
yeah.
It's a lot easier because you don't have to hold on to numbers. You don't have to try to remember things. You just let the calculator do the work. Okay, let's look at another problem here. This is the last law of sines problem, it looks like, in this section. So, all right, so angle J is 34 degrees. Angle I is 72 degrees. And little I is 206. Okay, do you see that?
Mhm.
So notice we have this pair right here.
And we have J pair.
well, we can get the other j, and that's what we got to find. All right, so now we're going to set this up. And this is where I like to put the unknown in the top left. So it's little j over sine of big J equals I over sine of big I. Okay. Now we have all these numbers, don't we? We've got J. Sorry, J. I'm sorry. No, we're trying to find J. We have big J. That's 34. So we're going to start substituting numbers. So J over sine 34 equals 206 over sine of 72. So I'd like you to try solving this way I just showed you, where you put this right here. You literally just move this sine 34 over here. You remember that from the last problem?
Yeah.
Okay, so I want you to do that. Give me 30 seconds to pull something off the stove. Be right
Okay.
back.
I get 121.12.
Sorry, what?
I get 121.12 as my final answer.
Good, that's correct. Okay. All right, well, I actually kind of like the way they did this. They didn't give you too many problems that were really crazy difficult to start out. I can't tell if this next section will be easy or hard. So we're going to look at it. We may not get through it, but whatever we don't get through, you can finish up on your own. The point is to yeah, okay. All right, so yeah, unfortunately, this next section requires a lot of explanation, and it's a little, again, it's kind of out of scope. Like, you won't see this again until trigonometry, which would be in pre-calculus, which is after you've taken this class and after you've taken algebra 2. So I think this is actually a good place for us to end the lesson for today.
Okay.
And just stand by for a moment, though, please.